Congratulations, you just got a new car. Goes pretty well, gets you places. There's only one little problem. It doesn't have a fuel gauge. Now you have a couple of choices to make. You could take the dangerous choice. Do you not look at the fuel and just hope you can make it there? Or do you go to the next step? Do you go invasive, pull over to the side of the road, have a look under the hood, see how much you have? But you have to do that all the time and it gets in your way. Or do you go for the expensive route? Over $5,000 a year, you'll get a fuel gauge that mostly works, generally, but it's still pretty invasive. These are daily decisions that a diabetic has to make. They could not measure their blood sugar level, which is incredibly dangerous for when you go low or even high, which is even worse than for a car. You could be invasive, or you could get a continuous glucose monitor for over $5,000 per year. Now, this continuous monitor works well, but the problem is nobody can afford it. And it further compounds where lower socioeconomic society are at higher risk of diabetes, and that society can't then afford the best care, which adds more and more costs to the government, to the individuals. My solution is this. It's a non-invasive pulse oximeter-like glucometer. It works using light at specific wavelengths. It uses LEDs to emit and detect this light, which makes it very spectrally responsive. And like pulse oximeter technology, it's able to be continuous. It's really low power. It's non-invasive. It can just sit on your finger or in a smartwatch. And it costs maybe $20 per device. And that's even before mass manufacturing. Here, I've got results of a trial I did with pig blood. So in the lab, have it shining through a glass vial, and you can see using two wavelengths, one that glucose absorbs a lot and one where it doesn't absorb. And in taking the ratio of that, you can see it fits very nicely to what's called the Beer-Lambert law, so how much gets absorbed in your slides. To further push the price down, I'm a big proponent of open source hardware. All of my work I'm releasing under an open source license, which means that anybody can access it, see what it does, how it works, which means many can contribute to it, which further lowers the cost of development. It's much easier to get through FDA approval, say, and for a startup, it lowers a lot of the costs because you're not patenting anything. It's a lot easier for development. So this is my idea to break the wall of unaffordable diabetes management to allow the whole society access.
Thank you, Jake. Right on time. Any questions for Jake?
Yeah, that was really good. Thank you. I was just wondering if there was any work you've done sensitivity or specificity of your device, I guess.
I haven't got that far on people yet. I had a less than 1% error. So my R-squared on that was, I think, 0.995 for measuring in pig's blood. And human blood is pretty similar. The main challenge is where pulse oximeters come in, where you're looking at the arterial signal, and it does reduce the signal. But I believe with the technology I've developed using LEDs to sense light instead of photodiodes, they're over 10 times more spectrally sensitive at the wavelengths that we want, which will get us a cleaner signal with lower noise.
Any other questions for Jake?
What will be your next steps?
What will they? People testing. So I'm currently doing ethics. I've got Māori approval currently, and it's just going through the Human Ethics Committee. We're doing a trial on people, so they'll wear it continuously on a finger cuff for a couple of hours, do an oral glucose tolerance test, and then use a conventional finger prick glucometer to measure your glucose levels so that we can calibrate it against the state-of-the-art current measurements.
Any other questions? How does it actually work?
How does it work? So glucose absorbs light, infrared light, so lots of LEDs, but none of them light up. So it absorbs some wavelengths better than others, so you're able to isolate here glucose absorbs well, here water absorbs well, and then here lipids absorb, here albumin. So you're able to, I have 6 different wavelength LEDs on here that are able to take essentially the sum of each of the absorption coefficients from the main molecules I'm looking at, and then they all would contribute to the total amount absorbed at each wavelength. So it's just a linear regression.
Thank you, Jake.
Thank you.